Statistical learning in a natural language by 8-month-old infants. What is the motivation? The motivation is driven in the idea that infants possess the ability to use statistical learning mechanisms to extract important information about word boundaries and detect novel words even in languages other than their native language. The author focuses on the ability to recognize isolated words after exposure to fluent speech in a foreign language such as Italian. The authors designed 3 different experiments. The first was to determine whether infants could segment anything at all with little exposure to Italian. The informants included 28-month-old infants recruited from a local birth announcement database. All infants are English learners, recognized with a set of Italian sentences, and tested on familiar words in comparison to novel words using the head-turn preference procedure. The 4 Italian words selected for this study was fuga, mello, pane, and tempa. Infants were assigned to one of 2 languages. Trials that contained familiar words for infants in language 1 were novel for infants in language 2, and vice versa. The familiarization phase consisted of exposure to repeated material. Specifically, each word was presented 6 times in 12 sentences, while the test phase included 2 familiar words and 2 novel words. This experimental procedure was repeated until infants completed 12 trials in total. The results showed that the average looking time was longer for familiar words than for novel words, as presented in the graph to the right. This suggests that the preference for familiar words allowed infants the ability to discriminate items presented during the familiarization phase from novel words, despite the use of a foreign language. The combination of few repetitions of each target word during exposure, paired with rich material, is likely responsible for this preference. However, another possible explanation is that infants have succeeded in the discriminating task by detecting frequency of individual syllables. In experiment 2, the authors focused on having equal frequency of exposure to syllables from the familiar words and the novel words. The experimental procedure remained the same alongside the 4 target words and with exposure to each syllable 6 times. The only difference was that the syllables pa and ta occurred in stressed positions and na and ma occurred always in an unstressed position. The results were similar. Infants preferred familiar words, therefore suggesting that infants are able to discriminate items from the familiarization phase even when the individual syllables in both the familiar and novel words occurred with equal frequency. It could be that infants are not only tracking syllable frequencies, but are able to discriminate familiar pairs of familiar syllables from novel pairs with familiar syllables. Therefore, they are tracking sequences of syllables, an ability needed to discover word boundaries in fluent speech. The final and last experiment was designed for a more difficult discrimination in which infants were tested on words occurring with equal frequency, differing in transitional probabilities. Instead of being tested on familiar and novel words, infants were tested on words with high and low transitional probability. Most of the methodology remains the same as experiment 1 and 2. However, this time, 32 8-month-old infants were recruited, and the words selected and tested for were fuga and mello as high transitional probability words, and casa and bici as low transitional probability words. With reference to the graph, results show that the average looking time for high transitional probability words were higher compared to low transitional probability words. This preference suggests that infants reflect a novelty preference for infrequency syllables in high transitional probability words. The overall implications of this study suggest that infants have the ability to use statistical regularities not only in their native language but also in a foreign language. The current results represent an important step in showing that statistical learning is robust to the complexities of naturally produced language. However, more research will continue to explore other regularities in speech. And that is all for today's presentation.